Welcome. Let's take a look at the safety system integrated into the new iiQKA.OS2. We call it Argus Safety, a next-generation platform for safety monitoring and configuration. This system builds on the proven architecture used in Sunrise for LBR EVA, iiQKA.OS1, and our Easy robots. What's new is the flexibility. Argus introduces a highly configurable, modular approach to safety. Instead of a fixed package, you can now tailor your safety system precisely to your application needs. If you're coming from the KSS world, you'll remember SafeOperation as a bundled license with a defined feature set. Argus takes a different approach, offering greater functionality along with scalable cost options. This slide summarizes those improvements. In traditional KSS safety, you had predefined options: safe operation, safe single break, velocity monitoring, and so on. With Argus, all these capabilities are still available, but now you configure only what you actually need. This brings significant flexibility and efficiency. We've also introduced valuable new features. For example, you can now monitor the entire robot arm, not just defined zones, for safety and collision detection. Fence safety zones have been improved as well. And importantly, Argus includes a full set of HRC features required for collaborative robotics. As part of our One OS strategy, you can configure collaborative easy robots in exactly the same way as industrial arms, simply adding the required HRC functionality where needed. One of the biggest changes in how we bring this to market is the introduction of a points-based licensing model. On the left, you'll see license tiers: small, medium, large, and extra large. Each tier corresponds to a point budget and a corresponding price point. You then allocate these points to the safety elements required for your specific application. On the right, you can see examples of how points are assigned. For instance, a cell safety zone, your fencing, costs 10 points. Cartesian spaces cost 3 points each, and safe tools are 2 points per tool. This allows you to build a safety configuration that matches your exact requirements. While this may seem complex at first, iiQWorks simplifies the process completely. It automatically calculates and manages point allocation for you. As mentioned earlier, this unified safety system spans our entire robot portfolio. From compact SCARA robots to collaborative systems, all the way up to our largest Titan robots. The same tools and principles apply across all configurations, ensuring consistency and scalability for any application. The feature set continues to evolve with each KSS release. We've already introduced versions 9.0, 9.1, and 9.2, with 9.3 scheduled for release this summer. Each release brings significant new functionality, along with improvements in performance, stability, and usability. At the current level, you already have access to most functionalities familiar from SafeOperation. This includes Cartesian workspaces, cell boundary prisms, velocity limits, and operation monitoring. Future releases will further expand capabilities, particularly in collaborative robotics. All of this functionality is fully integrated into the iiQKA.OS2 user interface directly on the robot. In the image on the right, you can see the safety ID. This is a critical concept. It ensures that a safety configuration is validated, approved, and traceable. Once confirmed, the system assigns a unique ID, allowing users to verify that the active safety setup has been properly certified. Let's look at some of the new capabilities in iiQWorks.Sim. This example shows how to configure a cell wall. Previously, in SafeOperation, this required manually entering coordinates, which could be time-consuming and error-prone. Now, you can define safety zones graphically using drag and drop. You still have the option to enter coordinates manually, but most users prefer the visual approach. Another major improvement is geometry flexibility. Previously, only convex polygons were supported. Now, concave shapes are fully supported, so you can define more complex layouts, like L-shaped areas, directly. This eliminates the need for workarounds using multiple Cartesian boxes. Safety configuration is now fully rule-based. In SafeOperation, configurations were relatively predefined. With Argus, you can combine multiple elements into flexible safety rules. For example, you can configure logical relationships, like AND conditions, where multiple criteria must be satisfied. Common elements include cell area or fence zones, work zones or protected zones, velocity monitoring. And in future releases, you'll see expanded features such as orientation monitoring and advanced HRC functions like force limiting. As you build your safety configuration, the Project Analyzer assists you in real time. It automatically determines the appropriate license size, small, medium, large, or extra large. It also tracks your point usage as you add safety elements, ensuring full transparency. For end effector protection, Argus continues to use a sphere-based modeling approach. However, configuration is now fully graphical within the Sim environment. You can easily add, position, and adjust spheres to accurately define your tool's protected volume. This allows for more precise and efficient safety modeling. There are also significant increases in system limits. Cell area prisms can now have up to 20 points, non-convex shapes are supported, up to 16 Cartesian boxes are available, up to 50 safe tools can be defined. Each tool can include up to 12 spheres, enabling highly detailed protection of complex end effectors. Another important enhancement is full arm monitoring. The system now also monitors the robot's rear kinematics, so areas like the elbow are protected as well. Safety rules can be configured in detail for each application. For every rule, you can define the stop behavior. A key enhancement is axis-specific safe operational stops. This is particularly useful for positioners or applications where certain robot axes are allowed to continue moving under safe conditions. Now let's move into a live demonstration. As shown earlier, most safety configuration is accessed through the devices area. You'll find a dedicated section in the project tree for safety configuration. At the top level, one important setting is 3D object interaction. Before configuring safety, you'll want to enable this option. Next, navigate to Safety Zones. This opens the Properties panel on the right, where you can define different safety elements. Protected zones, working zones, and the main cell wall prism. Selecting the cell wall adds a default shape with 4 points. You can add additional points as needed, but note that new points are appended at the end. So it's best to plan your geometry ahead of time. In the 2D layout, you can see the dark line representing the cell wall. It has 6 corners. Just for clarity, I will point them out. 1, 2, 3, 4, 5, 6. So I'll go ahead and add those additional points right away. Now I'll select the area and switch to Move mode for better visibility. This allows me to define and position each point interactively. I'll place the first point along the fence line. Then I move to the second point and adjust it directly on the layout. And now the third point. If you've used SafeOperation before, you'll immediately notice how much easier this is compared to manual coordinate entry. Here, the zone turns red, indicating an invalid geometry due to this elongated section. Once I adjust the final point, the zone becomes valid again. This makes it very intuitive to align safety areas with your actual layout. It's a significant time saver during setup. You can also configure hardware interfaces, such as fieldbus settings, directly in this section. Most of your work will be in the rule-based configuration area. There is a default safety configuration, but you can create custom rules as needed. Access the rule editor via the gear icon. From there, you can define additional rule sets. Here, I've added a rule set. Now I can add elements, such as an enabling input and velocity limitation. This is where you combine the exact pieces required for your application. So far, we haven't used any elements requiring points. Let's add a protected zone. As soon as I select a safety zone, the project analyzer is triggered. It informs me that a safety license is required. So I'll select the small license. Now you'll see in the upper right corner, license type, small, with 50 available points. Adding the safety zone uses 10 points. As I continue adding elements, the system automatically tracks point usage. If I exceed the available points, I can simply upgrade to a higher license tier. And that concludes this introduction to Argus Safety, the new safety system within iiQKA.OS2. Thanks for watching.
Thank you for joining us today. If you enjoyed this video, please like and subscribe the KUKA channel for more content. For practical training and workshops, visit the KUKA College. Stay tuned for more tutorials and insights.
Making automation easier.